Hi, my name is Gopi Kumar. I'm a program manager in the data group. I'm really excited to talk about building intelligent applications using the Cortana analytics process. Before we start with the process itself, let's understand what we mean when we say an intelligent application and contrast it with a traditional application. Traditionally, applications have been written to hard-code the program logic and with static rules which are based typically on expert logic and human intuition. And the actions are typically predefined and they have limited ability to react to change in data patterns. In contrast to that, intelligent applications allow you to use the data both from within the enterprise as well as from outside the enterprise in order to make predictions and learning from the data. And by this, it actually improves the customer experience. It also learns from the data, and it leverages cloud-hosted APIs. Examples of intelligent applications are all around us. For example, when you shop at an e-commerce site, there is a recommendation engine that is making predictions on what kind of products you are likely to buy. When you step into an elevator, there is a predictive maintenance module that's actually checking various sensors in the elevator and trying to make recommendations on when a particular part is going to need some maintenance. And companies are always trying to understand their customers better. So one of the things they try to understand is, okay, who are the customers who are likely to churn? So based on this, you look at historical patterns on customers who have churned recently and try to understand whether this particular customer is likely to churn. And based on that, you try to kind of create some actions like improving your customer experience or offering some kind of a promotion in order to retain the customers. Next, let's look at the recipes that go into building intelligent applications. At a high level, there are three main ingredients to kind of create your intelligent application. First, you start with data, lots of data. And again, as we mentioned, this data can be from within the enterprise, from outside your department, and also from the public data and data from social feeds. Then you take this data and try to make sense out of it using analytics tools and machine learning. And finally, the important part of building the intelligent application is also operationalize. By this we mean providing the ability for client applications to consume your machine learning models and reporting dashboards. So those are some of the three main ingredients that helps you build your intelligent application. Building intelligent applications require a whole suite of tools and technologies. So Cortana Analytics Suite is a set of products that make it simple to build end-to-end solution and build intelligent applications using them. So on the leftmost side, you see the different data sources. These can be business applications, custom applications, sensors, IoT, and devices. You need to bring all this data into the system. So you use information management products within the Cortana Analytics Suite, like Azure Data Factory, which allows you to create data pipelines, which lets you schedule jobs to bring in your data. You can have a Azure Data Catalog, which allows you to track all the data in your enterprise and external to the enterprise that you are using in your application. And finally, you have Event Hub that allows you to work with streaming data in real time. So once you get all this data, you need to store them in a secure way so they can be easily analyzed. So this is where the analysis components the storage components come in, which are Azure SQL Data Warehouse, which allows you to work with in a SQL-like environment. Or if you prefer a Hadoop Spark type environment, we have the Azure HD Insight, which allows you to store the data in a Hadoop cluster or a Spark cluster. And for extremely large data sets, petabyte scale, we built an Azure Data Lake Store, which allows you to work with very large size data efficiently. So once you have the data within your big data store, next step would be to kind of use analytics and machine learning products. So this is where we have products like Azure Machine Learning, which can process your data and run machine learning algorithms on the data. If you have streaming data, you use Azure Stream Analytics to bring in the data and analyze it in real time. And Azure Data Lake's analysis services allows you to query using a SQL-like language on the Azure Data Lake Store. And finally, you have the consumptions, which are either people or systems. So people can consume it through dashboards in Power BI, or use natural language queries using Cortana, and also use perceptual APIs like face APIs or vision APIs, speech APIs, and textual APIs. And automated systems can use our APIs that we provide for recommendations, churn, and forecasting. So the tools and technologies are one part of building your intelligent applications. You also need a streamlined process to build this application. So we have defined an end-to-end step-by-step process that allows you to be systematic in building your application. So you start with planning step, where you understand your business problem and the technical context under which your solution is going to work. Next, you are going to ingest the data using the data ingestion tools, and this can be again data from your enterprise and also from outside the enterprise. Once you get the data in, you need to kind of get a deeper understanding into your data, and data visualizations and other tools allows you to do exactly this. You also look at the integrity of your data, whether any part of your data is missing, some data is formatted incorrectly. So you get all these insights in the exploration step. So once you have your data, you have a good understanding of the patterns, you start to create some hypothesis on what type of data features can help you build a good predictive model. For example, an example of a feature could be, let's say you have a date field within your data. Let's say you want to convert that into like a season field based on the date. And if you think that the season field is going to help improve the predictability of your machine learning models, you would create a feature called season and create a feature to build your model against. So you build these features, and this is a very iterative step. You experiment with different features and then build your models. And when you build your models, you again try multiple algorithms and with different sets of features, and you evaluate your models for the performance. So once you build your model and you are satisfied with the model that you have chosen for your production environment, you need to expose it so it can be consumed by client applications. So this is where the operationalization comes into play, where you wrap it around APIs, which can be called from client written in any language. This can be like a web service type API. So those are kind of the steps. This is a very iterative process. You go back and forth between these steps unless you are satisfied with your model that it can be consumed within your application. So continuing on the data on the process, we also provide very technology-specific guidances, like how you would run through these steps using specific technologies. So the Cortana analytics process is a systematic data science process that provides guidances and walkthrough specific to the Cortana analytics suite of products. And it has both end-to-end walkthroughs as well as individual tasks that you would do using the Cortana analytics process set of tools. You can see the URL to this, the Cortana analytics process at the bottom of the screen. And we'll also point to you at the end of the presentation the resources. So now that we have seen the data science process and the Cortana analytics suite of products, let's now go into a live demo on how to use this process to build your own real-life application. I'm going to invite Wee Hyung, a colleague on my team, to demonstrate the Cortana analytics process in action.
Hi everyone, my name is Wee Hyung. I'm a senior program manager on the Azure Machine Learning team. Now what I'm going to show you today is how we can go about taking the Cortana analytic process that Gopi was sharing with you earlier, and then being able to take this process and systematically use it to build your next intelligent app. Let's get started. Now, let's start off with the data. The data that we're using today in order to build the intelligent app is the New York City data set. Now, this data that we have has about 12 months of data from January 2013 to December 2013. And using this data, we're going to first go through the process of exploring the data to see what kind of interesting insights we can derive from the data set. Now, in order to do this, we make use of Jupyter notebooks that's already part of Azure Machine Learning Studio. Now, I've already pre-opened a notebook, And in this case, we're going to take a look at what are the different kinds of pickup and drop off in different parts of New York City. Now, as I run this Python code, what this is going to do is it's going to connect all the way back to Azure SQL Data Warehouse. It's going to crunch through the query that you see on the screen. And finally, it's going to give you a visualization of both the pickup and drop off. This is going to take a while. Now, while this is happening, let me also walk you through other parts of the Jupyter Notebook. In this case, you see a query that we've just run and the visualization that was returned, right, showing most of the taxi ride originating from this area. Now, let's suppose you have made use of Jupyter Notebook or your favorite machine learning tool in order to explore the data. The next thing is to be able to take this data and be able to build a model out of it. Now, to do this, I pre-created an experiment. In this case, I call it an NYC taxi dataset regression experiment. And this experiment, we take a subset of the dataset. We make use of a regression model. And finally, we train the model using the data that we have. And finally, we evaluated the model. Now, Azure Machine Learning Studio enables you to build this kind of model really quickly. Once this model has been built, the next natural question is, how can you operationalize the model? Now, in order for you to operationalize the model, you can now then create a predictive experiment, which I've already pre-created. And in this predictive experiment that you'll see here, you'll see that this predictive experiment has the trained model. But more importantly, in this predictive experiment, you have a web service input and a web service output. Now, this allows you to very quickly publish this predictive experiment as a web service. Let me try running the experiment. Now, while this experiment is running, let me take you through the web service that I've already pre-published before this talk. Now, what you're seeing here is the web service that has been published. And you'll also notice that in this web service that gets published, there are two endpoints. One, which we call the request response endpoint. Two, we call the batch execution endpoint. Now, the request response endpoint is very suitable for you if you're building an application that's going to consume the output of the machine learning model. Now, if I were to click on the request response endpoint, you'll see the documentation that's been created for the request response endpoint. And at the same time, we also provide you with sample code in order to help you get started, whether you're using C#, whether you're using Python, or whether you're using R. Now, the question here is, given this set of web service endpoint that has been published, how do I go about creating a web application, or more importantly, an intelligent web application that consumes the output from this endpoint? Now, to help you jumpstart very quickly, you can click on the web app template for RRS. Now, once you click on the template, you'll get to a page that shows you to say, well, please create the web application. In this case, I'm going to create the web application. And it's going to take you through the step of simply creating a web app, leveraging the endpoint that you have seen earlier. Now, I could call this Build Conference 2016 NYC. And I'm going to select this to be my subscription. And I'm going to select an existing resource group. Now, once this is done, I can hit Create. And this is going to create a new web application that consumes the request response endpoint. Now, I'm not going to wait for it to finish creating. I'm going to show you the web application that has already been created. Now, let me click on this. In this case, I pre-created a web application that consumes the endpoint. And this is going to bring us to this website, which is nyctaxipredict.azurewebsite.net. Now, let us take a look at what is inside this website and how does it help you jumpstart the process of building your first intelligent application. Let's click on this. And you'll see that the web application that gets created, we have already pre-populated it with the metadata, right, which the request response endpoint provides. In this case, It has all the parameters that I require as input. And more importantly, I can slide this to show the different fare amount. And I could say, well, my trip time in seconds is about 98 seconds. My trip distance is about 13 meters. Can you help me predict what is the tip? Now, what is happening now when I click submit is this web application is making a call to the machine learning web service that we have just published. Now, the web service is going to then predict, given this kind of input parameter, what is the amount of tip that's returned. In this case, you see that the tip return is about $2.34. Now, the question here is, now that I have this web application, how does this relate to a web application that is useful to you in the context of the New York Taxi data set? Now, to illustrate this, let me show you the web application. Now, in this web application that we've created, we call it NY Rides. It allows you to behave both as a driver as well as a passenger. Now, I'm going to run the code that's powering this web application by going to Visual Studio. Let me launch the Windows application. Now, at this point, you'll see that we have started a web application which I can easily deploy to Azure. I'm going to fill in my nickname as Talk. And whenever I click on this application, I could say I want to be a passenger and I want a ride. Now, once I'm in this mode, it's going to say, hey, where do you want to be picked up? I'm going to say, well, it's downtown Manhattan. Where are you going? I'm saying I'm going to the airport. Now, watch what happens when I click Request My Ride. At this point in time, I place a breakpoint into the point where we take a simple application that you have today and integrated machine learning capabilities into it. In this case, this breakpoint was set at this point which says estimated tip. Let us take a look at what is inside estimated tip. Now, you'll see that this estimate tip invoke a request response service. Now, let's take a look at what is inside this method. Now, at this point, the web application is making a call to the web service endpoint, doing a prediction on the tip given the input parameters that's been provided, and is returning the results back. And this case is going to return a status code of success. Now, when that happens, it's going to return a set of JSON. And from this JSON, we're then able to extract the tip amount. In this case, it says that the tip is $1.90. Now, when this happens, we're going to write this back into a database. And why do we want to do that? You'll see in a moment. Is a write has been made. Now, but more importantly, if I were to get back to the NY Write application, I could say, now I'm in the role of a driver. Now, to a driver, I want to know which are the rides I can pick up. So let me click Be a Driver. And if you scroll through this list of rides that's been shown here, it shows that there's a pickup from downtown Manhattan, drop off at uptown Manhattan. Similarly, there was a pickup at downtown Manhattan, drop off at the airport. But more importantly, you see that the tips has been populated. Now, this tip is really predicted by the Azure Machine Learning experiment that we have operationalized. And more importantly, it has turned this application that you see here into an intelligent application, because now the driver can make a decision to pick up or not to pick up a passenger based on the estimated tip. Now, let's get back to the slide on what we have just seen. What you have just seen is an example of an intelligent application that we have built, and we leverage a model that does a prediction on the tip amount. At the same time, given this data set, you could also do very interesting kind of experiments on it. You could either build a binary classification model that says whether a tip will be paid or not be paid. Or it can be a multi-class classification model that says what is the tip amount range that is expected. Now, this provides you very rich capabilities in order to build an intelligent application. Now, let us just recap what we've just seen. We showed you the different services in the Cortana Analytics Suite. More importantly, Cortana Analytics Suite provides you with a set of services in order for you to build your intelligent applications. We also showed you a very systematic and iterative data science process, which we call the Cortana analytics process, that helps you take your data, go through a very systematic process of understanding the data by exploring the data, doing feature engineering, but more importantly, turning applications that you have today into very powerful, intelligent applications. Now, these are just some of the resources that can help you get started in understanding Cortana analytic process. My name is Wee Hyung, and together with my colleague, Gopi Kumar, we have shown you how we can use the Cortana analytic process to build intelligent application. Thank you for watching this session. I appreciate your time.